This is the COSE321 assignment 4 video, and in this assignment, our goal is to print out R0 to R5 register and CPSR register to UART port. And let me quickly explain about my code. And many my code is consist with many files, and my code is consist with total 7 files. And first file is csvasm.s, and this is the main logic. This is the main symbol of our our JetBoard our JetBoard platform. And in this main logic, this this code is simply act this code simply acts same as homework 2 sorting problem. And but the only difference is there are debug point macro in some in some locations of the main symbol code. There are total 7 debug point macro is inserted in here. And second is HAL file, and this includes UART register header file. And UART register is simply indicate UART base and register offset. So HAL UART.s in this file, putchar function is declared in here. This is implement This implementations is from the example code of our class website, and it's this symbol is act like putchar function. Putchar function. Its argument is a character and return type is void, and this function is just print out 1 byte character to UART port. So our high our high level implementation of printf is using this putchar function. Use uses the putchar function. And macro.s file is in the macro.s file there are some macros. First macro is UART macro, and this is also from the class website example code. So in UART port is initialized in here, and its bitrate, its baud rate is 115,200. We need to, so if we want to connect our computer to JetBoard with UART with serial port, we need to simply pipe this baud rate to the speed. So so I will turn on the board, and and let me connect. Let me connect. And this is and and the UART connection is established. And now if the code print out some data, then the the data is displayed in here. And second macro is debug point macro. And debug point macro. Debug debug point macro. This macro is just print out or R0 to R5, R15, and CPSR register to this UART port. And by using print register utility function, we I implemented it I implemented it in the other file. And by using this print register utility function, the register value is came out in this display. And after printout and after printout, see, re- after printout, you by using pop operation, restore all all register value to push it in the stack is restored in this section. In this section, this section, including CPSR and R02, R12, and R and R R13 to R15 register is SPLR and PC, and this is very critical register because this registers are very critical register they because they process the program's control flow and step pointer. So to store SP to restore SP, we I use the add operation to skip to skip the I use the add operation rather than pop operation, and or and only LR is restored by using pop. And this is the end of explanation of macro.s. And let me explain about our C file and our C code. Uh, our C code. Because of because of our specification is like this, there are we need to print out not only character, not only English character, but we need to print out decimal number and also hexadecimal number. And each hexadecimal number is related to the register value, stored, which is pushed in stack, which is pushed in stack. So I want to use I want to use a format string to print out this value. And to use format string, I need to implement the printf standard library printf function. So the stdio.c and stdio.h is the implementation of that function. .h .h file is simply define function prototype, and actual implementation is stdio.c file. stdio.c file. There are global character buffer in here, and this function is putstr function, and this function is used. This function uses putchar function. Oh, this function is uses putchar function. I already mentioned about this function in here. So this function simply print out the string buffer to the UART port, and and printf implementation is here. Printf implementation is here. To use a format string, I used the dynamic argument and the VA list to get the argument, and actual format string processing conducted in conducted in VS printf function. And so this function in the printf function, the what by using the for loop, the format string is read by for loop. And as we know, format string start with percent. So so this if block indicate this if block can get the format string, and by using the switch case block, each block it can process each block can process each format string. And also we need to we need to print out decimal and hexadecimal number. So we need to implement %x and percent %u format string and %u format string. And to implement this format string, we also need to implement u2a function, which is which get unsigned which get unsigned int integer and which get unsigned int integer, and it simply translates the unsigned int integer to decimal string or hexadecimal string and store it to the character buffer. So finally, vs printf function store processed format string to printf global variable. And lastly, by using putstr function, I already mentioned it. So by using putstr function, or or print the final string is printed out to the UART port. And this is the library function, implementation of library function. And in the util.c function, the print registers function is here. Is print registers function is here. Its argument is registers array, and first element index 0 is CPSR register value, and index 1 to index 16 is R0 to R15 register value. And it simply print out the register value using debug printf. But here is some here is some more processing part. be- Here is more processing part macro implement because of macro implementation and program execution logic. We need we need to we need to process we need to some process while printing out PC and SP value. S, PC and SP value. Because we need to use this code to debugging purpose. Let's back to the main symbol. If I if I print out if I if I print out all register value in this context, then this context, then our expected register value is in the context of here. After executing this after executing this in, instruction. So our expected PC value is here. Our expected PC value is here. But 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 after but ap- but while pushing R0 to R15 register, actual PC is here. Actual PC is here. We there are so because of pipeline pipelining, there are eight address gap between eight address gap between our expectation and real PC value. So minus eight i- minus eight is for this gap. By using this, we can get expected expected PC value. And also push operation is decrement before operation. This is mentioned in lecture 2. So in the macro, while pushing R0 to R15 register, SP value is decremented before pushing register value. So 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 previous so decremented SP value is stored in the stack. But but our our expected stack value is not the decremented value. So we need to print out our SP value plus 4 times 16 because we push it, we push it, we push it 16 registers, 16 4-byte register. So by using this, we can also get the expected SP value. And this is the, and this is, and this function is to print out our output data output data to ensure our output data is well sorted. And this is the end of my explanation of implementation. And let me quickly show the demo. This is the dem this is a demo environment, and I already I already built I already built and I break I break I inserted breakpoint in here to see my code where is well my code is well my code is run well. And let me quickly debug my code. Okay, this is the start. and and now here is the now here is the context of before executing debug point macro. And let's see the let's see the register layout. And let's see the register layout. This is the register layout before executing debug point debug point debug point debug point one. and and because because R0 to R0 to R14 register are restored after executing debug point. Let let's focus the PC is ended with 5 before. And now let's execute the debug point one. So I insert breakpoint in here and let's resume. And this is the and now the now the executing of debug point one is done. And let me see the and let me see the you want you want to print out result. And as I mentioned, except R15, all register is restored. All registers is restored. And I already mentioned R15 is ended 5 before. So R15 is well printed out. And all other register, let me compare. All other regis all other register value is well printed out. As you see, all other register value is well printed out, or including CPS star, value. And let's see more, let's see more, let's see more. Then this is the debug point 2. And the difference is PC is end with 650, and R1 register now R1 register now in here. R1 register is now in here. And let's see the memory layout. Let's see the memory layout and sign rendered to sign integer. And all value is zero, initialized with zero, because because our output data is initialized with zero. So this is the context of before executing debug point two, debug point macro, debug point two. And let me insert the breakpoint and resume. Now now debug point macro is executed, then serial output is here. Serial output is here, and R15 register is printed out, and all other register is were printed out, and R1 register is changed to output output data output data address. Okay, so our debug point macro is seems like well seems like execute well. And and let me and let me execute now in the debug point 9. So be- this is the context of before executing debug point 9, and all registers is here, and the PC is end with A90, and all register is like this, and CPSR is 800000 DF. And the macro. Let me execute the macro. Now this is the end of Now this is the end of macro. Now this is the end of macro, and your printout result is here. So Let's compare it. I think I think core value is well printed out, and I mentioned R15 is end with A90, and CPSR value is also well printed out. Then let me quickly ensure. Let me quickly let me quickly see after executing or sorting logic. So will insert I will insert breakpoint in here. Let's resume. I think we don't. I think I need to rerun the program. I think I need to rerun the program. So this is the sorting process. And now end of sorting. Now this is now this location is end of sorting, and as we and or 32 or 32 4 byte integer is where sorted in here, were sorted in output data. So our program is where our program were acting. Our program executed well while we while we inserted debug point macro. And I simply print out the whole output data to UART port. This is for debugging purpose, and because because percent because our we implemented the unsigned int format string. This is this is unsigned in this is unsigned integer decimal value. This is unsigned int decimal value. So if I pick this value, this is this is supposed to be -1 FFFF. So so the hex value is -1. -1 -1. So we so by seeing this, we can figure out acting. Our code is well acting. Our code is well acting, and this all registers can is printed out. All registers is printed out, and our I think it is well. I think it's act well. So this is the end of my explanation of demo code. This is the end of my demo of the my implementation of debug point macro. So I will submit seven this seven file to this seven file. So I will submit this seven file to the assignment result. So this is the end of my video. This is end of my video, and thank you for watching.